I am delighted to introduce Kathleen Biggins, the founder and president of Sea Change Conversations, a nonprofit organization dedicated to opening minds and building consensus about the changing climate. A nonpartisan, science-based organization, Sea Change Conversation bridges the political divide as it educates audiences throughout the country about how climate change will impact them personally, why there is urgency to address it, and how to forge consensus for action. The Sea Change Primer, which you are about to watch, is a presentation Kathleen has presented to almost 17,000 people in 32 states across the country. Widely hailed as an intelligent, dispassionate introduction to and illumination of climate change, the primer has been endorsed by businesses, political and social leaders, and enthusiastically received by audiences across the country. Welcome, Kathleen, and thank you for zooming in from the East Coast to join us.
Oh, thank you, Gina. It is such an honor to be with all of you tonight. Oh, today for you, tonight for me. And I'm very excited to have this opportunity to share our work with you. So whenever we walk into a room or a Zoom call to talk about this complicated issue, we recognize that we don't walk in alone. We say we walk in with three 800-pound gorillas with us. And the first 800-pound gorilla is the fact that we all know that the climate has always been changing due to natural causes. We've had crocodiles in the Arctic, we've had ice ages. But this time, scientists say it's different, that after a period of remarkable stability for the last 10,000 years, man, through our actions, are triggering a period of instability. And we're doing it at a time when there are about 8 billion of us on the planet today and close to 10 billion projected by mid-century. And we can't just pick up our lean-tos and follow the food and water resources as they react to a changing climate. The second 800-pound gorilla in the room with us is the fact that fossil fuels have been incredible friends to us. Before we discovered them, our lives were short and brutal. They have given us a vibrant economy and a high quality of life. But scientists say, if we continue to use them the way we have in the past, they will begin to do the opposite, actually harm our GDP and lessen our quality of life, especially for our kids and our grandkids. And the third 800-pound gorilla in the room with us is that this is a tough topic to talk about. Perhaps it has been banned from your Thanksgiving table. It was from mine for many years. But it hasn't always been this way. George W. Bush was elected on a cap and trade proposal coming in on his platform. There were multiple bipartisan bills introduced every single year of his 2 terms. In 2007, Newt Gingrich, a Republican leader, and Nancy Pelosi sat right next to each other on a couch and did a commercial proposing a cap and trade solution. And in 2008, it was on both parties' presidential platforms. Different ways of addressing it, but agreeing that it needed to be addressed. So what happened? Well, scientists who were active during that period tell us that when Al Gore won the Nobel Peace Prize for his movie on climate change, An Inconvenient Truth, it was a watershed moment. Something that had had begrudging acceptance across the aisle became labeled as a liberal issue. And suddenly there was a new litmus test of what makes one a good liberal or a good conservative. And the news media really didn't help. On the left, many wrote that in order to address climate change, we had to be anti-capitalist, anti-cow, and anti-car. And on the right, it began to be covered much more as a social war issue instead of a scientific one. Research shows that in 2006, about 50% of Fox's news coverage actually said that climate change was real. But by 2009, 90% said it was a hoax. So we had this hardening across party lines. But if you fast forward to today, most Americans understand that climate change is happening, and the majority agrees that it's being caused by humans. But where we really don't agree easily is on how to evaluate the risk. Is it an existential risk that will harm our economies and hurt our children and future generations, as the Secretary of the UN has claimed? Or is it more of a tempest in a teapot, something that will lead to greater government overreach? And if we pivot too quickly to address, could harm our children and harm our economies. And most of us are somewhere in the middle, wanting to do the right thing for our kids and our grandkids, but also not wanting to be sucked into something that can often seem over sensationalized. So how should we consider this risk of climate change? Well, we would suggest that we evaluate it the way we evaluate any large risk in our lives. And social scientists say we divide that risk assessment into 3 parts. What are they? So the first part of that risk assessment is how likely is it to happen? The second is how dangerous are the potential consequences if they come to pass? Are they ones we can live with? Are they ones that we really want to try to avoid? And the third part of that risk assessment is how difficult or expensive is it to avoid that risk? So let's jump into that first part. How likely is it to happen? Well, we know it is very likely and that it is actually already happening. And how do we know that? Because we understand the basic physics of how greenhouse gases affect climate, and it's been well understood and accepted for over 150 years. So let's go back to science class for a minute. When the solar radiance comes down, it passes through the Earth's atmosphere and strikes the Earth's surface. Some of that energy is absorbed, but quite a lot of it ricochets back out into space. And as it does so, it is at a different wavelength. And this wavelength is now captured by a teeny tiny portion of our atmosphere, less than 1%, that is made up of greenhouse gases, which we think of as carbon dioxide, methane, nitrous oxide, and even water vapor. Without this tiny portion being comprised of greenhouse gases, we would have a frozen planet. So they play an outsized role in modulating our climate. But when we add to them, it simply means they capture more of that ricocheting energy and re-radiate it back down to the Earth, warming us up and adding energy into our climate systems. Another way to look at this is the balance of carbon. I think we all know that there is a balance between plants and animals, but we may not know there's also a balance in where nature stores carbon, in the oceans, in the atmosphere, and in the Earth. And I'd like to call your attention to those 2 small words at the bottom, fossil fuels, because I think if we consider what they are, it will help us understand what's happening. So fossil fuels are little bits of plant and animal matter that fell from the sky millions of years ago, got silted over, and with time, heat, and pressure, got turned back into pools of elemental carbon, what we call coal, natural gas, and oil. And humans came along and said, wow, really rich in energy, really portable, really storable. I'm going to use it. I'm going to use it to warm my homes, to run my transportation, to build my factories, and to create vibrant, complicated economies. And life was good. But in doing so, humans were taking carbon dioxide that nature had sequestered out of the system deep underground and started pumping it up into the atmosphere at the alarmingly fast rate of about 40 billion tons of carbon every single year, much greater than nature ever does, and upsetting the balance that has existed since humans have been on the planet. And because we know that adding carbon dioxide in the air will force the temperatures to go up, it's no surprise that our temperatures have risen since the Industrial Revolution by about 1.2 degrees Celsius, which correlates to 2 degrees Fahrenheit. Now, I know 2 degrees Fahrenheit increase doesn't sound like such a big deal. It may even sound like a good deal on a really cold winter's day. But in fact, that small change is quite a big change for the average global temperature. We'll get into that more as we go into the presentation, but don't let those small numbers fool you. Another way we know climate change is happening is we can see it with our own eyes. This is a picture of the Arctic Ocean from about 1886 up towards current time. And what we're looking at is the Arctic ice, the mature ice that is depicted in white, melting and leaching away and being replaced by the immature ice and open water, which are depicted in light blue and dark blue. And the reason why this is so important is that mature ice is highly reflective. And that means as it is replaced by that open water and immature ice, more of that initial solar radiance will be absorbed by the Earth, and less of it will ricochet back out into space. And therefore, we are baking in temperature increases for future generations. Another way we know climate change is happening is because we can look back in time and see how today is different than yesteryear. And we do that through a discipline called paleoclimatology. And scientists like this one can look at proxies, things like ice cores that can be 800,000 years old, and find with them little air pockets that were captured when snow fell and froze over. And they can liberate those air pockets and discern what the carbon levels were going back 800,000 years. And what do the scientists tell us? They tell us that we are in uncharted territory. That for the last 800,000 years, our carbon dioxide levels have naturally fluctuated between about 150 and 300 parts per million. These were through the natural cycles the Earth always goes through ice age and thaw, and ice age and thaw. And then in 1910, we broke out of the natural cycles. And today, we're crossing over 300 parts per million. And today, we're close to 420 parts per million. And scientists say if we were to continue on our current emissions path, we would hit close to 1,000 parts per million by the end of the century. So hopefully you are with me that climate change is indeed happening. Let's move to that second question. How dangerous are the potential consequences? And as we go through the changes that are coming, I'd like you to focus on the big picture. And that's why we're going to spend a moment on this slide, which shows what has been happening over the last 20,000 years. On the bottom axis, we have time going back 20,000 years. On the y-axis, we have temperature from about 9 degrees colder to about 11 degrees hotter. The gold line is average global temperature, and the white are just milestones to give us reference points. So 20,000 years ago, we were in a glacial period of the last ice age. And there was a mile of ice over much of North America, and much of the planet was uninhabitable. And then over about 8,000 years, nature moderated, coming up to what more or less has been the average global temperature for the last 10,000 years, which is right around 60 degrees Fahrenheit. 60 degrees Fahrenheit is a really good temperature for our species, and it is not a temperature the Earth has been at very often in its long history. It's not as if that's the default temperature that nature or the Earth comes back to if we knock it off that temperature. And once we arrived at 60 degrees, we were able to settle down. We were able to farm, create agriculture, to have Mesopotamia and other civilizations form. And then we went along, you see that little hillock, perhaps a degree. That is when the Vikings were able to grow vegetables in Greenland. And that divot, which is 1.5 degrees, that's the Ice Age, where glaciers came down, disrupting life and food resources and causing great upheaval. Again, showing how a small change in global temperature could make for a big change on how people experience life during that time on the surface. And then you see the temperature going up, up and away, landing somewhere between 3.6 and 10.8 degrees Fahrenheit by the end of this century, depending on what we choose to do. So let's think about that. Nature had 8,000 8,000 years to go from around 7 degrees colder up to our average global temperature. And that 8,000 years, nature had time to march trees from Mexico to Montana and to create this incredible ecosystems and biodiversity that has supported us for the last 10,000 years. And then we, through our actions, are potentially triggering a similar delta in 100 years. That's scary, right? And that's what brought all of the nations of the world together to say, hey, we can't go there. We can't go to those high numbers because we aren't sure we'll be able to handle what nature throws at us. We need to stay at that 3.6 degree level, which correlates to a 2 degrees Celsius that we hear about in the press, or even better at a 1.5 degree increase, because then we think we may be able to handle what nature may throw at us. So as we go into these changes, I'm going to ask you to consider them through 3 specific lenses. The first is, how will these changes impact the jobs and the economy in your area? How will it impact your and your family's health and personal security? And also, how will it impact your exposure to geopolitical instability, which we experience as civil conflict, refugee crisis, or even as terrorism? And I had asked if we were live, if anyone could tell me why we are focusing on those specific lenses, but I'll just tell you. And it's because they are the 3 things that Americans say are most important to them when they go to make their vote. And we believe that climate change will negatively and profoundly impact all 3. So what are the changes that are coming? Well, I think you have been reading about them and experiencing them yourselves in California. Climate brings all sorts of changes, including drought, rain floods, fires, and increased sea level rise. But let's start with heat, because heat is actually the thing that is causing many of these other changes to follow. It kind of starts the cascading momentum of these dangers. So how hot has it become? Well, this is a graphic from NASA that shows us what temperatures have changed from the beginning of the Industrial Revolution coming up again to today. When it is blue, the average temperature was colder than normal, white was average, yellow was warmer, and red is hotter. So as you can see at the end, the red really comes crescendoing in, and that's because we aren't just breaking records, we're really shattering them. Another way to look at it is this bar graph that shows the 10 hottest years ever recorded have all been since 2010. And that means that all of your seasons are getting warmer, but the summer seasons are the ones that are most concerning. Your temperatures are hitting new records, including last summer when Santa Rosa hit 117 degrees. But what does that mean going forward? Well, Climate Central, which is a nonpartisan scientific group, took 23 different models. So this is not the worst case scenario. And they averaged them all together to see what your grandkids could experience in your area at the end of the century. And they forecast that if we were to continue on our current emissions scenario, your summers there would feel like summers in India, which is south of Palm Springs in the Coachella Valley today. And while that is alarming to me, looking at what could happen to some of our southernmost cities is even more frightening. This is what is projected for Phoenix if we were to continue on our current path, and that is that their summers would feel like a summer today in Saudi Arabia, many continents away. But we know that heat is only part of the equation. It's the mixture of heat and humidity that is so dangerous, especially when it hits 105 degrees, which is when even a healthy human cannot sweat to keep their bodies cool down and to keep safe. These are a list of some of our favorite cities whose populations are growing and economies are growing that are projected to have many months of danger days when during that day the temperature is above 105-degree heat index. And this includes, of course, El Centro right there in California. So what do we think will happen to these cities when temperatures get this high for such a long duration? What do you think will happen if we look through those three lenses? Well, for their jobs and economy, we know that human productivity goes down as heat goes up. We know that agricultural yield goes down as heat goes up. We know that transportation systems tend to degrade and break as heat goes up. We know that they will need to build more infrastructure to keep their population safe, and that also tends to degrade at high heat. So clear hits to jobs and economy. What about that second one, personal health and security? Well, as we mentioned, heat can cause heat stroke, but it also exacerbates many other illnesses, including cardiovascular disease and lung disease. It also causes premature births. And as heat rises, crime levels go up. In fact, heat is the #1 weather killer of all weather occurrences. So clear hits to health and security. What about that third one? What do you think scientists mean about global instability? Well, as hot as it will be in the southern parts of our own country, it's projected to get even hotter in places further south in Central America and the northern part of South America, which means that many people there will be forced off their lands. And scientists project migration unlike anything we've ever experienced against our southern borders. And interestingly, they also predict that as the century goes on, people from our own deep south will begin moving north to stay in a better climate and to follow the economic activity as it moves north. And of course, heat isn't just in our country, it's all around the world. This was a graphic that just snapped my head back, so I wanted to share it with you. It is from the World Economic Forum. And they projected what heat levels could be like if we continued on our current emissions. And what they see is that big parts of the world, including all of the shaded areas in northern South America, in Africa, in India, and over all the way to Australia, could experience summer-like conditions that today are only experienced in the Saharan desert, with an average summer temperature of 104 degrees. And frighteningly, 1/3 of the world's population is projected to live in those shaded areas that will be impacted. So let's move off of heat and move quickly to drought. So because heat dries out the soils and dries out our plant material, it leads to prolonged drought. And this is something that the West has been experiencing quite significantly recently. I know your recent deluges have made it much better, but I know it is still very much top of mind. And as we go into the century, droughts are expected to extend, and 100-year droughts are expected to happen more frequently. And that has a direct impact on our food resources. The World Resource Institute took a look at where our crop yields would fail or increase as we hit a 3 degrees Celsius increase or a 5.4 degrees Fahrenheit increase, which is really where we will go at a moderate emissions level. That's where we go if we start cutting back on our emissions. And you can see that the red areas, which are all in the heavily populated areas, begin to see real decline. And that includes some of the areas that are most important to feeding the world, whether it's the Rice Bowl out in Asia, our own Midwestern breadbasket, or as we like to say, our salad bowl and wine cellar of California that provides so many important foods to all of us. But we know that food isn't just on land, it's also in the oceans. And what many of us may not realize is that CO2 mixes with ocean water and turns into carbonic acid. In fact, our oceans are 30% more acidic than they were before the Industrial Revolution. And that is really bad news if you are a creature that makes your shell out of calcium, including hard clams and oysters and scallops, but also things at the very bottom of the marine food chain, like these little sea butterflies, which are critically important to salmon and mackerel and finfish that we eat. In addition, we are heating up the oceans. They are absorbing a lot of that excess heat that we are creating. And in some areas, the oceans are already 4 degrees warmer. And this has real ramifications for our hurricanes. We are not seeing more hurricanes, but we are seeing more powerful hurricanes. And we are also seeing hurricanes develop and stay strong much further away from the equator because the warm water can continue to feed them and give them the energy they need to stay destructive further away from the equator. And that acidification and that heat together is bad news for our coral reefs. Many of them are being bleached out, and because they are the nurseries for 24% of all marine sea life, this is really, really concerning. Now, remember I said at the very beginning of the presentation, those small numbers really matter. Well, this is a great time to kind of focus in on that. The most recent International Panel on Climate Change report projected that if we could keep our temperature increase to a 1.5 degree increase, something that we are fast approaching, we could potentially save up to 30% of our coral reefs. But if we go all the way up to a 2 degrees Celsius increase, they anticipate we will lose them all. So every smidgen of a degree increase is worth fighting for. So let's move on to heavy rainstorm. I know that this is a very familiar sight to you, whether it's roads that have been flooded out or rivers that have been flooded out. And these rainstorms seem to be happening everywhere, and that's because they are. It's simply physics. The warmer oceans evaporate more water. The warmer air can hold more water vapor. For every degree Celsius it becomes warmer, it can hold 7% more water vapor. So it just means that when conditions are right, we are having more of these torrential downpours instead of restorative showers. And it is happening everywhere, not just in places that normally get rain, but even in places that are experiencing drought. When they do finally get the rain, it comes in this dangerous form. And again, this will only increase as we get further into the century and we continue to warm up. Another thing that's being impacted is our surface water. And again, I know this is very top of mind for you, since you've gone from a drought to a deluge. But what is happening globally is that our rain or our precipitation is falling later in the year as rain, and our snowpacks are melting earlier in the year in the spring. And that means there's less water coming down into our rivers, our dams, our reservoir, and our surface water for all the things we need it for, whether it's for our cities, our farms, our hydropower, or for our wildlife. And again, this too will get worse as we go through the century. Another area that is really perplexing is sea level rise. We know that the seas have risen about 9 inches since the Industrial Revolution, and we know that that rise is accelerating. Why is it increasing? Well, our glaciers, our land ice are melting, and that water is flowing down to the sea, and our oceans are getting hotter, which means they are thermally expanding and getting bigger. The projections for you guys are about 1 foot more by 2050 and 3.5 feet more by 2100. Interestingly enough, sea level rise is not uniform. Some areas will have higher and some will have lower. But the scary thing about it is that we know much more has been set into motion. What we don't know is how fast it will come. And that will give us, without having that, it's harder for us to decide what we can protect and what we will need to yield to the sea. Let's move quickly to health. And this is a really important thing that climate change is impacting in ways that most people don't really think about. In fact, we have an entire presentation just on climate change and health that we'd love to share with you on another occasion. But some of the things that CDC has highlighted is the fact that climate change will impact our lung health. And that is because the higher levels of CO2 cause higher levels of pollen. And already this year, we've seen pollen alerts across the country because pollen has been so heavy. It will almost triple by the end of the century. And that has direct implications for people with allergies and people with asthma. And also that has direct implications for our public health budgets because both of those constitute a big hit to our public health budgets. Another thing that we have to keep an eye on is the fact that our nasty little pests, our fleas, our ticks, our mosquitoes are expanding their geographical footprint and are active longer through the year. In fact, the CDC has said that diseases from these insects have tripled since the beginning of this century. And something, again, I don't need to tell you about, but climate change is exacerbating our wildfire season. Scientists say that the fact that things are just tinder dry, that our summer-like conditions are extending so much longer through the year, makes it so ripe for a conflagration when a spark happens, whether it is from nature or whether it is from man activity. And we know that the forest fires will continue to get worse as we go further into the century as well. And we know that we will have fires in areas that used to be much more protected from them because they are too getting more dried out. And the damage, of course, is in the local area, but the air pollution really goes far and wide. In fact, we have had times on the East Coast where we've had a code red day that has come from the fires out in California. And we also know that forest management is a really important strategy as we deal with forest fires. This picture shows a sequoia forest, one that had prescribed burns and one that had not. Both had then been faced with a forest fire. And you can see one was much more resilient. And I have to give a shout out to Sonoma County because after 2017, they really took fire management to heart and invested quite a lot in it to try to make your forest more secure going forward. And if it feels like we're having more and more of these disasters hitting, it's because we are. This is a graphic that shows how billion-dollar disasters have almost quadrupled since 1980. And I need to be very clear and say that some of this is because more humans and more of us are building more expensive places in dangerous areas. And so we're kind of making the bullseye bigger. But scientists say that indeed our disasters are getting much more frequent and are getting much more ferocious, more dangerous, and more expensive. The way they put it is it's almost as if climate change is loading the dice or stacking the deck. And this is leading, as we mentioned a little bit earlier, to a lot of population movement, especially in places that have poor governance or weak institutions, or where they are just not wealthy enough to be resilient to the changes that have come from these natural disasters. And of course, they are happening, as we noted, right here in our own country as well. There's a new phrase that's being bandied about. It's called the Great Displacement. And the reason they're calling it displacement instead of migration is because it's not happening from one area to another, but in fact, it's happening in lots of little areas, whether it is the drought damaged areas and farmlands in Arizona, or the coastlands in Virginia, or in Louisiana, or the fire areas out by you. People are being displaced and sometimes they cannot come back. And we, again, are going to see a lot more as we go forward. In this past year, 3.4 million of Americans were made to leave their homes just because of natural disasters. And it's a familiar story for you. I'm sure many of you know this map by heart, as you guys have experienced the new phenomenon called weather whiplash, when you have one extreme to the other coming right upon each other without giving enough time to recuperate and prepare. And all of this has direct implications for our economic health. This is from the BlackRock Institute, not a green organization. And what they took a look at was how climate change would impact local GDP. And anything that is orange or darker shows loss, yellow stays the same, and then green shows some growth. And if you step back and think about some of these hits that we have spoken about, whether it is longer droughts, more extreme hotter days, more deluges, more forest fires that can harm your agricultural product and put smoke taint onto your grapes, and you consider that you are so dependent on agriculture and tourism, you can see how your local economy needs to become more resilient and harden and prepare for the future as well. And I'd be remiss if I didn't talk about climate change's impact to our biodiversity and our ecosystems. This is a beautiful tableau that I see every fall in my community in Princeton, New Jersey. And I hope that when I have grandkids, they will have a chance to enjoy this fall splendor. But scientists say that these trees need the cold to flourish, and they're beginning to march northward. And out by you have the iconic fog. But climate change is impacting that as well. The fog is already diminished, and it's expected to be much more diminished over the next few decades. And the fog is so important to your redwood forests. So how do we put a price tag on losing our sacred and iconic spaces that mean so much to us today? And how can we accept that our actions could be the cause of future generations never seeing this type of splendor? Now, I'm going to ask you to step back and think about what I just shared with you. I shared with you a lot of projections from groups like NASA and NOAA, who we normally look to keep us safe. Does that mean those projections are spot on? Of course not. They are just projections. But the question isn't whether they are 100% right. The question is whether they are credible, because anywhere else in our lives, when we faced potential consequences this significant, we would take action to avoid those risks. So let's think about whether or not you have fire insurance or earthquake insurance, right? Or especially fire, because you do that because it would be cataclysmic not to. And you probably do the smart things of closing your fire doors and buying smart appliances and doing everything you can to mitigate that risk. Scientists say that possibility of climate change harming us significantly is much greater than our house burning down, but we aren't according it the right respect. And that's an important part for all of us to think about, is how do we relate to and respect and react to this risk, because it is coming quickly at us. Now, I'm going to probably guess, even though I can't see your faces, that I have totally depressed you. So hang with me, because we're going to move into the third part of this risk assessment. And I think there's a lot to be optimistic about. So let's evaluate how difficult or expensive it will be to avoid the risk. And this is really, I think, where the good news comes in, because we now know that it is much less expensive and much less painful to make the transition to lower the risk than to continue on our current path. The cost of inaction now is clearly less than the cost of action. Why? Because we now understand the cost of climate change. We are paying for it as taxpayers right now, paying for repairing after all of these natural disasters, and also to kind of prepare for the new normal of nature, building new infrastructure, whether it's a $14.5 billion wall at the bottom of Louisiana, or the $60 billion that's been asked to protect the Texas coast, or the $125 billion that New York had been considering to protect its harbor. These are real numbers. And again, it's taxpayers that are on notice to pay these. And at the same time that we are spending more right now for climate change, the cost of moving to a lower carbon economy has dropped so precipitously, it makes sense to do so, whether or not you believe in climate change. So why is that? Well, it's because our new forms of energy, our wind and our solar, and the battery storage, which enables us to use them over a bigger portion of our economy and our electricity, have dropped so precipitously, they are much cheaper today than a fossil fuel. In fact, at the end of last year, our clean energy was 40% cheaper than natural gas or coal. And that is translating to new capacity coming on that is really skewed towards the cleaner energy. In fact, in a report on all of the new generation that has been approved for 2023, 86% of it was fossil free. Only 14% of it was natural gas, and there was no coal. And that means that we are experiencing real savings because of our use of these renewables. As you can see from this graphic, which comes from Texas, they saved $11 billion last year because of the renewables in their mix, where they, especially during their high heat periods where they had those heat waves. And in fact, when you add it all up, they saved almost about $30 billion over the last decade. And this means that using these savings, we could make this transition to a net zero economy by 2050 without spending more. I'm going to say that again. According to the National Academies of Sciences, we could transition to a net zero economy by 2050 without spending significantly more. And the reason that we can do this is we can take the dollars that are currently appropriated at fossil fuels, and we can also add in the dollars that are currently spent on all of the diseases that burning fossil fuels cause through air pollution. And the two together should enable us to make this transition in a very economical way. And importantly, that same study shows that this transition will grow more jobs, up to 1 to 2 million more, and these will be spread across the country, not just in a few geographical areas. And we also know that we can do a lot more. Why? Because other countries are, but also because your state is showing us the way. The United States this past year had 39% of its energy in non-fossil fuels. That included nuclear, renewables, and hydro. You all had 59% and have the goal of being 100% by 2045. You have also spread the clean energy move into other energy sectors, outlawing new gas stations to be built, and also trying to keep natural gas from being piped into new construction. Again, really leading the country. But in order to meet your goal, you are going to need to ramp up your renewable production. In fact, you're going to need to build it almost at a rate of 3 times as what it is currently being installed at. And we know that it's important that other countries are stepping up, and it's not just the United States trying to make this change alone. In fact, 136 countries that represent over 90% of global GDP have made similar pledges to become carbon neutral by mid-century. We also know there's a lot of great new technology on the horizon. What we have experienced today is just the beginning of an innovation and a revolution that will bring many changes. What will they look like? Well, one thing that will happen is that we will have much better transmission system. Our current transmission system is a bit like our highway system or our road system before we built the highways. They're very balkanized and they're falling apart. We need to strengthen them to protect them from hackers and to protect them from natural disasters. And in doing so, we can build them in a way that will allow us to integrate much more of this clean energy and get it to our population centers. And at the same time, there are major strides being made in batteries, both at the utility area and at our personal level, which enable us to have much greater flexibility in using these new sources of energy. And once we have a cleaner grid, we need to electrify everything we can, whether it's our cars or the heating for our homes. And importantly, we should note that as of this year, electric cars really have become quite cost effective. For a long time, they've been a lot cheaper to maintain and a lot cheaper to fuel and to own, because they last much longer because there's so many fewer parts to break. But for the first time really this year, we are seeing comparable models being at the same price with a regular combustion engine. So as we go forward, we anticipate a lot more growth within the EV area, and we are seeing it on a global basis really accelerating. And heat pumps too are kind of the new darling. In fact, last year in America, for the first time, more electric heat pumps were sold than natural gas furnaces. And we know that by putting these technologies together, especially if we put solar panels in our house and batteries on our wall and have that electric vehicle and other electric appliances, we become part of the solution. We become a mini power plant that can power our own needs when we want it, can even sell energy back to the grid in the future when it is needed. And that is critically important because we have to be very thoughtful and careful about where we install this new renewable energy, because we need to protect our natural spaces and our farmlands and do this transition wisely. But this transition will take time. And we need to make sure that as we taper off, our economy is stable. And that means that we will continue to use fossil fuel for the near and midterm. And to do that, we need to find ways to make it safer. And one of the things that many people are excited about is our ability to capture the carbon and keep it from going up into the atmosphere. This is a plant that actually takes captured carbon and puts it under basalt rock. And when water trickles down, that carbon turns back into rock and therefore is sequestered for a long, long time. Another thing that's really exciting is direct air capture. I think of it as a huge vacuum cleaner that sucks carbon dioxide out of the air and then allows us to use it for useful products, things that we can market. This plant is actually in Switzerland and uses that carbon dioxide it pulls from the air to sell to a Coca-Cola factory to put fizz in our seltzers and our Coca-Cola drinks. But there are many things we can do from captured carbon. We can make many of the things that we currently make from the carbon that we mine from the ground, such as fuels or fertilizer or even fish food. And even some esoteric things are being explored, like turning the carbon into diamonds and vodka. And fusion energy is also scintillating. I think we all know that fusion is the power of the stars. It's the way the sun creates its energy, and humans have figured out how to create that energy right here on our planet. It has always been out of reach, but now with all of the major breakthroughs in AI and magnets and lasers, scientists say we are now on the cusp to really having the ability to harness this type of energy. Just last year in the Lawrence Livermore lab near you, for the first time, they were able to have more energy come out of the reaction than they put in to force the reaction, which was a big benchmark. I had the opportunity to interview the head of the Princeton fusion lab, and he told me it's not a question of if we can get to fusion, it's a question of whether we decide this is where we want to invest our dollars to get to a zero carbon type fuel that could be used for a wide range of applications. And that gives me a lot of hope because other countries are banking on it as well. And green hydrogen is probably the other darling of the sector. This is when you take water and clean energy and break the water molecules into a hydrogen gas molecule. It can be used a lot like natural gas. It can be used in transportation and manufacturing. Some have called it the Swiss Army knife of new energy. And again, our country and many others are investing heavily in the idea that this could be in our arsenal as we go forward. We also know that nature has an incredibly important role to play as we face climate change. And that's because if we changed how we use nature, if we kind of started to play by her rules instead of trying to force her to play by ours, meaning going back to more regenerative agriculture and protecting our natural spaces, we really could absorb about 30% of the excess carbon. And that means protecting the places now from development and also looking for ways to grow them. Again, we're talking about kelp forests, we're talking about peatlands, we're talking about the rainforest. All of these are major carbon sinks. We need to keep them in working order. And there's some innovation happening even in our natural approaches. This is a picture of Ovaltine, which is a ground up volcanic rock. And when it weatherizes, it absorbs quite a lot of carbon. And so scientists are exploring putting it on beaches where the wave action will force that weatherization quite quickly, or even in some of our fields. So even in working with nature, we have a lot more innovative tricks up our sleeves. But we are in a race, and right now we are losing that race. We are still on that red line path. Our current emissions last year were higher than any other year. We have made many pledges, and many countries have put forward policies that would bring our levels down to closer to that brown line, which is real progress. But where we need to get is to that green line, where we really become carbon neutral as we get towards the middle of the century. And to do that, we have a lot of work to do. So what can we do? Well, we need to all become climate leaders. We need to realize that this is not an issue for faraway people and faraway times. It is our issue, and it will harm us and our children and our grandchildren. And therefore, we need to step forward and take action. We need to leverage our power as a voter, whichever side of the aisle we sit on. We need to make sure that people who are in power bring solutions, and there are many different approaches. There's not one way, but they need to be talking about how do we make this better. We need to reward the companies that are moving. They are driving so much of the change. And we also have to remember that not-for-profits are playing a critical role in educating policymakers and creating the change at the local and state level. So please consider them when you are considering your charitable support. And with that, I will segue to Gina so she can tell you what is happening right there in your backyard and how Sonoma Land Trust is acting to counter the threat of climate change. Thank you.
Wow, Kathleen, thank you so much. I'm sure we're all feeling overwhelmed and hopefully inspired by everything that you were able to share with us. So thank you so much for this presentation. All right, so you're all here because you know about Sonoma Land Trust, and we appreciate you joining on this webinar. So I'm sure you're thinking, wow, a lot of that information pertains to what we're doing here right now in Sonoma County. And I thought I would just share some of that information with you. We always like to talk about how we're the first generation to really experience these dramatic changes of our climate, but we're also the last generation that are capable of doing something about it. And thankfully, our organization and many organizations like us are out there doing that work right now. So as Kathleen described, we have 5 ways that we experience climate change: drought, heat waves, sea level rise, wildfires, and flooding. Lucky us. So that last segment she talked about using nature to buffer us from the worst effects of climate change are really nature, what we think of as nature-based solutions, right? These are the ways that we can restore nature to protect us. And this includes addressing the damage caused by humans. We've altered our waterways, our floodplains, and destroyed habitat that really could be helping us. Our solution is to revitalize our working ecosystems that will be more resilient to extreme weather conditions while advocating for climate adaptation policies and infrastructure. And that speaks to that last piece Kathleen was talking about. It's crazy. We've had a lot of rain, but we've been in a historic drought for a long time. And this is a picture of Lakeville Creek. This is a restoration project that we're embarking on. And the reason why it's so important, if you can see this graph here that kind of highlights what we're seeing in front of us. When we take a dramatically eroded creek and we restore it, the water is not just being able to just go down one channel, but we're slowing it, we're spreading it over the landscape, we're raising the water table and spreading it more widely. And some small facts about this. So over 500,000 people rely on the Russian River for their water, which is kind of significant. 43,000 people rely on groundwater, and that's why this restoration works. This is where we get our drinking water. 21.8 thousand acres of crops rely on groundwater, and over 59,000 dead trees were surveyed last year alone because of this drought. Again, our solution, we feel that the best way to address drought is through regenerating the water table and the natural aquifers that sit underneath the land. We know that we're not going to be building any more reservoirs and damming up infrastructure, which is costly, it's expensive to maintain. But if we just revitalize the land, it will do the work for us. Heat waves, as Kathleen mentioned, these are extreme, but what we also don't really talk about is how that they're the #1 climate killer. Heat waves cause more deaths each year than any other climate event. And as you recall, in September, we had a 117-degree day. We had weeks and weeks of oppressive heat, and it was a lot of stress on our power grid. We had alerts from our local utility agency telling us we had to reduce our use. It was something that we all felt. Our solution for heat waves is our Nature Nearby strategy, which targets neighborhoods without parks to bring free and equity-based relief to communities that need it most. We know that neighborhoods near nature are up to 8 degrees cooler. Sea level rise. This is a picture of our bailens and the logs that we put in recently to help anchor our wetland restoration project. Again, we know that the water level is rising. It's not just rising at the sea level, but it's also coming up and pushing up our groundwater, and it's coming up to the surface. And it is dramatically changing our roads, our infrastructure. I love this, that the water is pushing the groundwater to the surface, and underneath the roads and railroads, our homes can actually float. It's something we've, again, noticed in the Bay Area. Our situation and our solution is through our adapting to rising water strategy, which focuses on restoring marshes before they go underwater, and our wetlands to create buffers for the rising tides, the eroding winds and waves, and protect our shorelines from that impact of the rising sea. Wildfires. Here's a picture of our team on our Glen Oaks Ranch doing a prescribed fire. We know that if we reinstitute good fire onto the land as part of our land management practice, that our trees, our grasses, our infrastructure, our natural infrastructure will become more resilient for when those high winds, dry conditions, and lightning strike that create those catastrophic wildfires. Our solution is to thin the forests, to ensure that the prescribed fires are put into ecosystems that help build the resilience, in addition to coordinating with our neighbors and our partners to do this not just on our preserves, but across the county, so that we're really building a hardened infrastructure for the entire community. Flooding. So you saw the picture of Petaluma. Here's another one. We know that 75 to 85% of our wetlands have been lost to infrastructure. And without those wetlands, we don't have our natural buffers, our lungs, right, of the river to really take care and filter that water inland. It just rises. So frequent high tide floodings continue, and higher tides can now create clear sky flooding, which I think we saw today. Our land restoration here is also key. Building tidal marshes that create that shoreline buffer are really integral. You see it at the San Pablo Bay with those tidal marshes. They absorb that increased water. On the land, we restore streams, wetlands, and floodplains to give water a place to slow down, spread out, and eventually recharge our aquifers. So we feel that as much as we've got these challenges ahead of us with climate change, that we also have the solutions. And we know that our work is working, and it will buy us time while we're waiting for those other technologies to come online and really get us in a forward momentum in a much more dramatic speed. We have a track record of conserving and restoring ecosystems for over 47 years. And we believe that by strategically restoring the lands with the most potential to buffer the effects of climate change and enhance habitat for the diverse wildlife that we share, that we will be able to implement the most effective, economical, and productive solutions currently available. As an investor in our future, I would welcome you to think about Sonoma Land Trust as a part of that strategy. It's an investment in protecting yourself and for the future generations to come. I'm going to start to wind us down a bit. We have a really nice closing. Nancy says this was a really excellent webinar and discussion. Thank you, Nancy. You really model excellent communications on these topics. Thank you. We really firmly believe as an organization that the solutions are right under our feet. We can do this work. And we hope that together we can have more conversations, we can be educated, speak passionately, encourage others, vote, do what it's going to take in order to prepare us and buffer us for what might come. We invite you all to, again, to visit c-changeconversations.org for more information. And you can also email info@c-changeconversations.org, and also visit sonomalandtrust.org. We have wonderful programming, outdoor events going on. It's wildflower season. Come on out and get your naturalist on. So thank you, everybody. Thank you, Kathleen. Thank you, Mariana, for being here and helping us translate this. And we hope you all have a wonderful evening.